Tell me what you notice about number 16. Okay, it got bigger. How do you know that? The preimage and the image, right? So where is the preimage? The smaller one on the top, right? This is a plane A, so that's the preimage, and this is our image. So from here to, from the preimage to the image, it is an enlargement or a reduction? Enlargement, okay? It's getting bigger, okay? The shape, the rectangle is getting bigger. So, but what do we know about the preimage? Only one side is given, right? Only one side, we know the side length. But what do we know about the image? Everything. We know everything we need to know about the image. So what does that tell us? Are we going to be multiplying by our scale factor? So we're going to be going from here to here. We're going to be going from preimage to image. No, we're going to be going backwards. Before, everything we've done, we've taken our scale factor and we've multiplied it by the preimage points, and that gives us the image points, right? Right, that's what we've done yesterday. That's what we've done yesterday. That's what we did yesterday, right? And that's what you've done on other homework problems, if you've got to your homework so far, okay? But since we're going to be moving backwards, we're going to be going from image to pre-image. What does that tell us we're going to be doing? If we multiply moving forward, what are we going to be doing backwards? We're going to be dividing. Okay, we're going to be dividing by our scale factor. Okay, so that's why I wanted to talk about number 16, because it's different than what we did yesterday. It's a little bit different than what we did yesterday. All right, so let's find our scale factor first, and then go from there. Sound good? Okay, so how do we find, what measures our scale factor? Scale factor equals the image divided by the preimage, or the new divided by the old, right? All right, so which of our numbers do you want to use from our image? 5? Which 5? The one on the left or the right? The left. I have to use this one on the left. Why? Because on the preimage, that's the only one I know, right? Okay, so I'm going to compare 2 and 5. So what's going to go on top, 2 or 5? 5, because that's from our image. So our scale factor is what? 5/2 or 2.5. Okay, so now we're going to work backwards. Okay, so let's try and find letter Y. Okay, so we're going to take our side length that we know that matches that side. So that would be 5. Okay, hold on, I'm going to do these in corresponding colors so you can see. Okay, so light blue and light blue correspond with each other, yes? Okay, so we are going to take 5, and we're going to divide it by our scale factor, 2.5, and that's going to give me a side length of 2. Okay, which makes sense because what do you know about rectangles? Opposite sides, parallel sides are the same, right? So that makes sense that 2 and 2 would be the same. Okay, then we're going to do the same thing with 7.5. What, the orange that I just highlighted, what does that match? Z, this side length right here. So we're going to take 7.5, divide it by 2.5, and that's going to give me 3. Hold on. Okay, so what happens if we did it the way we did it yesterday? Then we would do, say we did 7.5 times 2.5. What's 7.5 times 2.5? 18.5. Does that make sense that this side length would be 18.5 when this side length is 2? Does that make sense? No, so does it make sense why we're having to work backwards through division? Because you're using the scale factor in the opposite way. Before, we were taking the scale factor and we were blowing something up, right? Or finding the difference between the two, finding the scale factor between two shapes. But if you're working backwards and you're trying to find the pre-image from the image, then you're working backwards, okay? And it makes sense too because, like I said, you end up with 18.5 and a side of 2. Well, that doesn't seem like scalable to 7.5 and 5 as side lengths, right? They should be pretty close in size. 18.5 and 2 are not close in size, okay? So this does not work when we're working backwards, okay? So then what does that tell you that the side length of x is going to be? 3 also. Okay, it matches its opposite. Number 5, what are the 2 types of scale factor, or the 3 types of scale factors that we can have?
Enlargement.
An enlargement? Okay, tell me about an enlargement.
Enlargement is bigger than 1.
When the scale factor is larger than 1, okay? And then what's the other type?
Reduction.
A reduction, okay? And the reduction has to be less than 1 and greater than 0. Very good. Okay, so it has to be in between 0 and 1, which tells us that it has to be some kind of small fraction or small decimal, right? Okay. And then neither, right? Neither. So what happens when it's neither? It's just 1, because anything multiplied by 1 is itself. Okay, that's the identity property. All right, so a scale factor of 3.5, is that number larger than 1 or less than 1?
It's larger than 1.
Larger than 1, so this is going to be an enlargement. All right, what about number 11?
Number 11.
Number 11, we are determining the scale factor. Okay, so how do I determine the scale factor? What did we say for number 16? Scale factor equals image divided by pre-image. Okay, remember I said I want work shown for each problem? This would be an excellent thing to write down for number 11. Okay, that scale factor equals the image divided by the pre-image. Okay, and then what am I going to compare? What numbers am I going to compare? Is it going to be the whole ordered pair divided by the whole ordered pair? No. Just the x with the x or the y with the y. Okay, why do I have to compare x with x and y with y? They're the same thing, right? They're like terms, basically, right? So what would you like to compare, the x or the y? X, sure. All right, so I'm going to take 4.5 divided by 3, and this tells me how many times does 3 go into 4.5? Well, it goes in 1 time and another half, right? It doesn't go in a full another time, but it does go in another half, okay? So our scale factor then is 1.5. Okay, how can I write 1.5 as an improper fraction? Nope, as an improper fraction.
Oh, it would be.
Very good. 3 over 2. 3 over 2.